This video is going to cover a lot of the concepts we've been talking about in ratios, equivalent ratios, and unit rates. Therefore, there are going to be some things in this video that are going to be a bit of a review. That's okay. The goal here is for us to cover all of those concepts and use them to solve real-world problems. So let's get into it right away. So just as a review of some of the things we've been covering, we've been working with equivalent ratios. That means equal fractions. And if we look at this problem here on the left, we have been trying to solve for the value of x by finding patterns in the problem. Well, if I look down here on the bottom, I notice that 4 times 3 is equal to 12. Therefore, if we follow that same pattern and do 2 times 3, we end up getting an x value of 6. And I like to rewrite the problem to make sure that what I did makes sense. And both of these fractions are equivalent to 1/2. Therefore, our x value of 6 would make sense. For the problem on the right, it's similar but not the same. Once again, we're going to try to find a pattern working from one fraction to the other. And I notice that 6 divided by 2 is equivalent to 3. Therefore, if I do 8 divided by 2, my C can be an answer of 4. Once again, I like to rewrite my two fractions to make sure they make sense. And it is true that 6/8 and 3/4 are equal. So this is what we've been covering, finding patterns to work from one fraction to the other. Multiplying by 3, dividing by 2, doesn't matter. We can multiply and divide by any number as long as we have equivalent ratios. But what we've been hitting are problems like this, where there is no pattern of multiplying a whole number times one of these to get to the right side. So there are two ways to solve these problems, and I'm going to show you both of those ways. My personal favorite is to simplify one of the fractions before I start to see if there is a pattern. I just might have missed it. So if I divide both of these numbers by 3 right away, the fraction on the left simplifies to be 1/3. And if that simplifies to be 1/3, now there is a pattern working from one fraction to the other. 1 times 5 is 5. 3 times 5 is, our n value must be 15. So that's one of the ways to solve the problem. The other is being willing to use decimals. So what I'm going to do is I'm going to rewrite this fraction over here. So what I know is I know 3 times something is going to be equal to 5. What I can do in this situation is I can look at these two numbers and simply divide one by the other to figure out what this value should be. So I'm going to do 5 divided by 3, which is a decimal or a fraction. What I can do is I know that this is equivalent to 1 2/3, or I can just leave it as just 5/3. So I'm going to erase this and rewrite. So I know that 3 times 5/3 is equal to 5, and I can prove that by multiplying these two fractions up here, which gives me 15/3 or 5. Therefore, if I take 9 times 5/3, I should get my value of n. So 9 wholes times 5/3 gives me 45/3, which I'm going to do long division here to try to solve this. So this gets 15 remaining, and that'll be equivalent to 5 1s. Therefore, my n value has to be 15, which is what I got for the problem on the left. So our answer ends up being 3/9 equals 5/15, which is true. They're both equal to 1/3. So the two ways to solve this problem were, on the left side, I simplified my fraction and then found the patterns from before. On the right side, I was willing to use fractions and decimals in the pattern, working from one fraction to the other. Both are correct. You pick the one that's better for you. Let's do that pattern one more time. Once again, we're going to break down the problems into two different methods and then find the one that works best for us. First thing I'm going to do is I want to simplify the fraction on the left. So I'm going to divide both of these numbers by 2 because they are even. Even numbers can always be divided by 2. So I now get this number, which is nice because the pattern is now a little bit more obvious. If I multiply both of these numbers by 3, they should be equal to the fraction on the right. Therefore, m must be 18. Now let's do the strategy from before, where we have to be willing to use some fractions or decimals. So 10 times something has to equal 15. So what I'm going to do is I'm going to do 15 divided by 10 to figure out what that something is. Well, 15 divided by 10, both of these numbers can be divided by 5, which gives me 3 halves, which is 1.5 or 1.5. Therefore, if I do 10 times 1.5, that will give me 15. Therefore, if I do 12 times 1.5, it will give me m. So I'm going to do 12 times 1.5, which I'm going to write like this. And remember, there is one digit behind the decimal point. 2 times 5 is 10. 1 times 5 is 5, with an extra 1 is 6. We have our 0 in the ones column. 1 times 2 is 2 in the tens column. 1 times 1 is 100. And remember, I have my one decimal. So m must be 18, which is what we had before. So let's do a story problem just to showcase why we're doing these strategies and how we can learn to solve them. So Aubin learned to sing a total of 10 pieces of music over the course of 5 weeks of lessons. Okay, so I like to underline the important stuff. 10 pieces of music over 5 weeks. How many weeks of lessons will Aubin need before she will be able to sing a total of 18 pieces? Okay, so what I'm going to do is I'm going to make this into a ratio up here. We have 10 total pieces over 5 weeks. And that ratio must be equal to, she has a total of 18 pieces. And we want to know how many weeks that will take. Okay. So once again, same thing we've done before. It's 10 fifths is equal to 18 over x. And x is our pieces. You could do either method, but personally, because 10 and 5 look like they can be divided both by 5 right away, I'm going to use the simplifying strategy that we did before. 10 divided by 5 is 2, and 5 divided by 5 is 1, which makes sense. She got 2 pieces a week on average, which is 2 pieces a week. Then we solve with 18 over x. Our pattern says that 2 times 9 should be equal to 18. So 1 times 9 should be equal to x. And x should be 9 weeks. So our sentence here to answer the question, is Aubin will learn 18 pieces in 9 weeks. And that is about all the strategies we need for now. As always, if you have questions, please let me know so we can work through them together.